Hi and a very good day. In this video, we will be discussing on the flow pattern transition and water holdup of gas-liquid flow in the horizontal and vertical section of a continuous transportation pipeline. We will be starting off with introduction. The objective of the experiment is to investigate the flow pattern transition and to investigate water holdup during oil-water-gas three-phase flow by considering both a horizontal section and vertical section of a transportation pipe simultaneously. We're moving forward to the description of the experiment. This is the design of the experiment, the schematic diagram of oil, water, gas three-phase flow loops, which consisted of power, the system, a metering system, and a mixing line. All the experiment were conducted by using white mineral oil, distilled water, and air. Yellow dye was added to the oil to differentiate its water visually. These are the properties of water, oil, and gas phase measured at atmospheric pressure and at temperature 20 degrees C. As you can see, we have density, viscosity, and surface tension for all three materials, and the formula below is for the calculation for the density and temperature of white mineral oil, viscosity and temperature of white mineral oil, the surface tension of white mineral oil, and the surface tension of distilled water. As shown in the picture is a instrument for water holdup that has been designed for the experiment. As the relationship of water holdup and the mean voltage can be expressed by deriving the mean voltage equation with the volume fraction of the three phases.
Okay, now we go to the analysis of the oil, water, gas three-phase flow. The factors affecting the gas-liquid two-phase flow are listed as follows: gas phase, liquid mixture, geometric parameter, bond recognition, and the gravitational acceleration. As can be seen, these are the dimensionalized form of the formula that in the slide before. The equation before also can be simplified as shown here, and the value needed also can be found in its table. Now we move on to the flow pattern map. The probability density function (PDF) of the instantaneous cross-sectional water holdup is measured by the water holdup instrument, and visual observation from the video camera were used to determine the flow patterns. Four main flow patterns that were observed in the study in both horizontal and vertical section were plug flow, annular flow, slug flow, and chain flow. The flow pattern in the horizontal section, which resembled plug flow, was equivalent to the slug flow observed in the vertical section. Conversely, the slug flow in the horizontal section was akin to the chain flow in the vertical section. When the USG or USM values were low, the vertical section displayed slug flow, while in the horizontal section, buoyancy caused the bubble to rise to the upper part of the pipe, resulting plug flow. In contrast, at high USG or USM value, the horizontal section exhibits slug flow due to significant inertial forces of the bubble, whereas in the vertical section, the bubble is integrated, leading to the formation of the churn flow.
The next part of the discussion is the water holdup. In this study, the water holdup instrument was employed to measure the steady-state water holdup in the horizontal and vertical sections of the pipe. However, the measured holdup data for the horizontal section at high superficial velocity ratio values were considered to be less reliable due to the conductance placement being parallel to the flow direction. There are two sections to this part, and where part A and part B can be seen on the slide. For part A, three graphs were obtained, and the relationship that can be observed are as follows. Meanwhile, for part B, the three graphs were obtained and the relationship can be observed are as follows. Next, the graph shown depicts a comparison of the predicted water holdup and the experimental data. The developed correlation from formula shows a good agreement with the experimental data. The final part of this presentation is the conclusion. In conclusion, from the studies that have been made, it shows that the change in flow pattern and water holdup during oil pipeline transportation is important for the proper design and operation of the pipelines. The other observation and findings during the study are shown on the slide. That's all from our group. Thank you.